Hello, my name is Andy Kurum, and this is my lab partner Rufus Simon, and this is our Fischer chess clock project on an FPGA for ECE 524 fall 2013 with Dr. Mirzai. And Rufus is going to start by introducing the hardware to us.
This is a Spartan 3E development board with a Spartan 3 FPGA on it. This is an I/O expansion board. There is 4 7-segment displays which can display 2 digits each. There is a push button cluster here, and you see that the room is dark because with the lights on, the 7-segment display cannot display the digits properly, so we turn the lights off.
Yeah, and now this is a Fischer chess clock, and what a Fischer chess clock does is it operates like a regular chess clock, except the fact that it will have a secondary clock when one of the players, this will be player 1 and this will be player 2, when one of the players runs out of time, a secondary clock will kick in, and then every time that player who already ran out of time makes a move, it will add 15 seconds to their time. And the reason that this was implemented is in order to make the games a little bit more exciting and forcing people into making more moves within the given time in order to just earn some time back. So what we're going to do is first we're going to demonstrate how this thing runs normally, meaning that it will initialize to a, Rufus is going to initialize it right now, go ahead. It just initialized to 40 minutes. Both players have 40 minutes to start with, and now when player 1 makes his move, he will click his button, and player 2's time starts counting down. These are player 2's seconds, and these are player 2's minutes, 39:53. It keeps on coming down. When player 2 makes a move, player 2's time stops, and player 1's time starts to count down. And then when player 1 again makes a move, as you can see, player 2 counter clock, whatever you want to call it, counts down, and then we'll go back to player 1 one more time. And this is what happens. If the game ends within this session, players can click the reset button and go back to the beginning at 40 minutes. Now, we also would like to demonstrate the secondary part of this situation, but we cannot do that while these things are set at 40 minutes because we cannot wait 40 minutes. So Rufus is going to push in a different initialization file which has, what's 0 right now? Can you please initialize it? Thank you. Now, we just initialized the clocks to 15 seconds. Let's say the game has been going on for a while and both players only have 15 seconds left. Now, player 1 makes a move, and player 2's time, player 1 needs to make a move, there you go. Player 2's time starts to count down, and player 2's time is going to run out. Player 2 at this point sucks. He just doesn't know what he's doing. So his time is going down, When the secondary clock kicks in, it automatically, without us touching any of the buttons, it will automatically reset back to 20 minutes. Now the secondary clock kicks in. Player 1 is on clock 1, player 2 is on clock 2, and the FPGA knows that, which is why when player 2 now makes a move and puts player 1 back into the charge, player 1 starts counting and player 2 will get its 15 seconds back. Now when player 1 starts counting down, player 1 is going to drop into stage number 2. This shows that they can be in 2 different stages independently. When player 1 drops there, and player 1 makes a move now, player 2 starts counting down, and player 1 gets a 15-second bump. And we can just go back and forth this way. They can just ramp their time up back into 40 minutes, 50 minutes, whatever they need it to back into. But usually things don't go that fast. Professional chess players usually take more than 50 seconds to make their move. Anyway, again, this is Mr. Simon and Andy Kurum demonstrating our Fischer chess clock. Thank you.
Thank you.